Alright, so in this unit what we're going to do is discuss the laws of exponents. So exponents are pretty much just exponential degrees of a constant or of a variable. So for example, 2 squared is, well, the 2 is the exponent, right? So 2 squared is 4, and this right here is an exponential expression. So now let's say we have 3 squared. Well, that's 9. That's also an expression that is exponential. Now, how about 3 to the third? 27, right? So now we can rewrite 3 to the third as 3 times 3 times 3, right? Which is the what the 3 to the third means 3 times 3 times 3, which is also 27. And we can do the same thing to all of these. Now, what if we had 2 squared times 2 squared? So right off the bat, I mean, you can just figure out what that is by figuring out what 2 squared is, which is 4, and then it's 4 again, so it becomes 16, right? Or you can spread this out to 2 times 2 times 2 times 2 times 2, right? Because it's 2 here and then 2 here, which is also, wait, sorry, there's one extra 2 there, so which is also 16, right? And, or what you can do is use the laws of exponents, use the laws of exponent addition, which is this right here. So x to the a times x to the b is equal to x to the a plus b. So this is the first law we're going to be talking about. So I think this is called, I mean, let's just call it the laws of exponents. One of the laws of exponents. So let's circle this right here. Let me make sure I circle a nice red color, or orange. Alright, so this is the first law. So now let's utilize this a little bit. So let's say we have 3 squared times 3 to the 5th times 3 squared. Now, you can figure this out by, if 3 squared is 9, 3 to the 5th is something, times 9 again, then you can figure out what the value is. Or you can use the laws of exponents and then get one expression with one exponent. So the law says x to the a times x to the b is x to the a plus b. Let's simplify it a little bit. Let's just say it's that. So 3 squared times 3 to the 5th, well, that's just 3 to the 2 plus 5, right? We're just going to use that law, which comes out to be 3 to the 7th. Now 3 to the 7th is a fairly large number, so we're just going to leave it as 3 to the 7th. Now, what if we had 2 squared, let me write it right here. What if we had 2 squared times 2 squared times 2 to the third? Now I think this should be solvable. So we can use the laws of exponents once again. So we know 2 squared times 2 squared is 2 to the 4th. And then we have another 2 to the 3rd. So that becomes 2 to the 7th, right? And 2 to the 7th, I believe, is 128. Let's double check. 2 times 2 times 2 times 2 times 2 times 2 times 2. Is that 7? Yeah. So that's 4, that's 8, that's 16. Times 2 times 2 times 2. 32 times 2 times 2. 4 times 32 is 128. Yes, so it is 128. So so right here we used the laws of exponents and we figured out that 2 to the 7th says 128, and we didn't have to multiply it out like this. Now, if we had the variables, we would do the same thing. So let's say we have x squared times x to the third. Now we don't know what x is, but it doesn't matter, right? So we're just going to use the law, right? So it's x to the 2 plus 3, which comes out to just x to the 5. And x could be anything, as long as it's the same value, right? Because x is equal to x, right? So the bases have to be the same. So you can't use this law for 3 times 3 to the 2 times 2 to the 2. This is not going to be 3 to the 4 or 2 to the 4. That is absolutely wrong. So they have to have the same base, right? So now in the next video we're going to be talking about the quotient rule of exponents, and we're gonna find ways to utilize that as well.